linear algebraic manipulations. Everything is based on NumPy arrays only. We have to we must definitely get hold on NumPy arrays. Okay, this is useful. We'll use NumPy arrays again in deep learning after 2 months, but we should get it now. Okay. So once after NumPy arrays, right? Tomorrow and day after tomorrow, we'll see data distributions. Tomorrow data distributions, the statistical concept, and then inferential statistics we'll see. Okay. Or maybe I'll show you a simple algorithm, linear regression algorithm, and show you the complete end-to-end process of executing a data science project and all that. And then we'll jump into more theoretical stuff. Okay. So NumPy arrays are homogeneous multi-dimensional arrays. Multi-dimensional arrays are matrices. We can say them as matrices because NumPy handles all the linear algebraic concepts. SciPy handles all statistical concepts. NumPy handles all the linear algebraic concepts. Pandas handles all the data pre-processing, whatever that statistical stuff and the visualization and all that. So you need to import NumPy like this. Import a NumPy as NP, and then I am creating a NumPy array here. Somehow I missed this LST1. LST1 is equal to, I created a list here, 1, 2, 3, 4, right, with 4 values, and I'm printing that. Okay, I use this LST. Right, I can take this, and then I can create a NumPy array like this. np.array is a method, is a function present in NumPy, which takes the list as an input and creates a NumPy array. If you look at this, this is one-dimensional array. Okay, when you look at this NumPy array and the list, right, you see the difference is that the commas, right? In list we will have commas. In NumPy array will not have commas while when you print it. And then there is shape attribute. Like in data frames, NumPy arrays have got shape attribute. The shape attribute will show you what is the dimensionality of it. Generally, the shape attributes outcome, not generally. The shape attributes outcome is a tuple. When I say tuple, there will be commas like this. There will be brackets, and then there will be a comma, right? When there is only one value in a tuple, let me try to show you that. T is equal to. Oh, I cannot do that. Okay, I cannot. Maybe I can do this like this. So it will create. It will not throw error. If you try to print it, right? It's a tuple with one value. Okay. So when the array is one-dimensional, then we will have a 4 comma like that. Right? It says that it is one-dimensional, and then 4 columns are. I shouldn't say columns there. There are 4 values in the array, and we have lists here and arrays here. Right? Why do you need another data type? Because this NumPy has got methods. We'll see those functions which will make our life easy in doing linear algebraic calculations. Why linear algebraic calculations we need to understand? I'll show that also today. Okay, with an example. In machine learning, how these linear algebraic calculations are useful, I'll show you. There is nothing we need to implement. All are present in these modules. We need to know how to use them. To use them, we need to know what the concept is. Okay, I'll cover mathematics also, a little bit of linear algebra also. Okay, so this is an array, right? Now we wanted to create a 2-dimensional array. So I have taken list 2. This is list 1, and this is list 2. And then I created list of lists. See, this list of lists is I enclosed list 1 and list 2 inside a list. Okay, and then I passed the list of list to array. Right, this is the numpy array. And then when I created numpy array, see that it actually, that is one dimensional array, that is one dimensional array. Both are enclosed in another array. Right? So that is 2 by 4, 2 rows and 4 columns. Okay, it's a 2 by 4 matrix. If I print this one, right, list of lists, just list of lists I wanted to print and see. See that the structure, right, when you print a numpy array, it actually clearly appears as a 2-dimensional array. But when you print list of lists, right, it actually spread across. Right? So when you are practicing, right, you will not know the difference between list and the numpy array. So I'm just trying to show you the difference. And then the shape attribute actually shows you the dimensionality. Okay, and one more point here is, I said that numpy arrays are homogeneous in nature, right? Homogeneous in they can handle homogeneous data, not the heterogeneous data. Lists can have tuples, Boolean objects, strings, numbers, everything together. But I said numpy arrays can handle homogeneous data only. If I put one of the values 5.0 here, let me show you the type. Right? If you say D type here, it is actually showing you that it is integer. Right? If I make one of the values as 6.0, now I create it. See this? Everything changed. Right? Everything changed to float. Now you see float 64. While creating an numpy array, you can specify the data type also, D type. So you can generally say D tab is not working. So there is a help in what you call it, Jupyter Notebook. Use types half of the word and then say type the tab. It will actually show you D type or D types. D type np dot float 8, I will say. No, float 8, I think. Float 16. Float 16 is there. Float 8 is not there. See that? So why did I reduce the data type size? Why did I reduce the data type size? In general, when you are creating the data structures, you should be careful. If there are million values in there, if you already know that it is not going to occupy more than 16 bits, if you create 64 bit type, right, it is going to occupy too much space, right, 4 times more than what is needed. Okay, so you can specify the data type. If you don't specify the data type, if one of the values are float, the whole thing becomes float. If all are integer, it actually takes integer. See that? Even int 8 is enough for this particular data type, for this particular data. Ndim is going to give you how many dimensions we have. It's a 2-dimensional array, right? Rows and columns are there. It's a 2-dimensional array. If you have rows, columns, and depth also, then you call it as 3-dimensional array. So let me try to give you a brief introduction to multi-dimensional arrays here, because in deep learning we'll anyway have to use it, and it is a must. Right? When you are doing the what you call it as NLP and computer vision projects, right? Definitely you have to handle multi-dimensional arrays. So we will have examples and all that, so no need to worry. We have created all the code examples for everything here. So in short. So here, right, what I said, this is a 2-dimensional array. The 2-dimensional array is like this: 1-dimensional array, 1-dimensional array, on top of it another whatever, right? Like that it is. But we can actually visualize it like that. One-dimensional array is enclosed in another brackets is a two-dimensional array, right? And then if you have these kinds of two-dimensional arrays enclosed in another, right? This is one more two-dimensional array, right? This is one more two-dimensional array. Suppose that that's another two-dimensional array, right? And one more two-dimensional array. Right? If you have three of them, they are like plates in a row, right? If you put another bracket on top of it, it becomes a three-dimensional array. What is the dimensionality of this? 2 by 4, or maybe 1, 2. I'll put values also 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's a 2 by 4 matrix. This two-dimensional matrix is a 2 by 4 matrix, and there is a depth, right? So what is the depth? 3, right? There are 3 two-dimensional arrays enclosed in one more bracket, so the depth is 3. So you can actually say 2 by 4 by 3. Okay, this is called as channels last. Okay, but in Numpy, when you actually create a array and try to look at the shape, what is the shape? It actually gives you the dimensionality like this, right? So it will print, generally it will print 3 by 2 by 4. So it generally takes channels first, or the representation. Okay. So when we actually learned the matrices in our childhood, right, we would have represented the matrices as like this: rows, columns, and depth. Okay, but in Numpy, it actually shows you depth first, then rows and columns. Okay, I'll show you in a moment, how to create a three-dimensional array and all that in a moment. But now to know the concept. If you want to create a four-dimensional array, right, we can do that. How do you create four-dimensional array? There will be, think that there is, this is a kind of box, right? This looks like a box. Do you see a box here? Right? Do you see a box there? Visually, it looks like that, right? Guys, are you able to understand?
Yes, yes.
Each of those is a kind of each of those lines is kind of a two-dimensional. This is one two-dimensional array, another. 4 two-dimensional arrays are there. It's a box, right? If you want to create a sorry, the three-dimensional array, right? If you want to create a four-dimensional array, right, you will take another box here. This is another three-dimensional array. Okay, another box here. This is another three-dimensional array. Right, another box here. This is another three-dimensional array, right? And then enclose everything in brackets. It becomes a four-dimensional array. Now this three-dimensional array has got suppose that there are so this is not end of this concept. I'll explain again and again. Don't be worried, right? Suppose that there are 4 depth here, and there is 2 by 4 here, right? 2 by 4, and maybe 5 depth will take, right? Maybe one more I'll add there to reduce the confusion. Right? So what is the dimensionality of this three-dimensional array? Can you tell me in Numpy terminology, not this terminology, What's the dimensionality of this three-dimensional array here?
5 to 4.
5 by 2 by 4, right? 5 by 2 by 4. And how many of them are there in this total box, brackets?
4.
4, right? So we'll get 4 here. Right? 4 by 5 by 2 by 4. This 2 by 4 is always at the rows and columns. The last dimensionality mentioned, right, is always rows and columns. This is the depth, and this is the higher layer, 4 by 5 by, right? If you want to have 5-dimensional array, right, you can have this kind of box of boxes more, and 6-dimensional you will have like that. It is, got it?
Okay.
So on a 3-dimensional array, if you say endim, right, it will give you 3. On a 2-dimensional array, when I did endim, it is giving 2. So let me show you that. Okay. So here I'm going to create. We have. I think I already have it. Yeah, here. We have methods called as zeros and ones. Okay. So let me try to take 5 by 6. So zeros is a method which actually creates 0 arrays, an array with all zeros. See that? Why do you need an array with all zeros? In our deep learning, we have to manipulate data. Before we manipulate data, right, we have to create dummy arrays. There we'll use zeros, and there is a method called as ones. Right? If you say ones, it will create an array with all ones. There is a method called empty. Create array with all empty values. You know, here it created with ones, right? When I call empty, it created ones. It depends on the memory situation. Whichever memory it picks up, whatever values are there, it will actually show you. I don't know why they named it as empty. Generally, empty means it should create an numpy array with all nulls or zeros. But you know, when I use empty array, right, it always works weird. It shows some value. So reliable things are ones and zeros. Right? Zeros is a method which actually creates zeros. If I create one empty now, create 0. See that? Before, whatever statement I executed, that same thing, that same memory it is taking, empty array. It is not reliable. Okay. So let us look at zeros method again. So I'm actually trying to show you how to create a numpy array. Okay. Here we created numpy arrays using lists. Simple one-dimensional list created one-dimensional array. List of lists array created a two-dimensional array. Now we looked at the data types, and now we are looking at how to create arrays with ones and zeros. Okay. So if you look at this ones, right, that is actually the function. Every function will have brackets, right? That is function. Inside it, we are specifying the dimensionality. The function is taking the dimensionality of the array that needs to be created. 2 by 3 means 2 rows and 3 columns. If I say 3 by 3, it's going to create 3 rows and 3 columns. Okay. So now you see that, right? So if I say 2 by 3, it is creating 2 rows and 3 columns. If I add 2 here, what happens? It will create a 3-dimensional array. A 2 by 3 matrices will be there. See that? So sorry, 2 by 3 matrices. Till here it is a 2 by 3 matrix and a comma, right? And then this is again a 2-dimensional matrix and enclosed inside those brackets. Okay, initially the numpy arrays are going to be a bit confusing. I'm actually trying to demystify that. Let's see, this 2 by 3 is the rows and columns. 2 rows and 3 columns. 2 rows and 3 columns. How many are there? 2. Okay, if I say 4 here, before that, it is going to create 2 by 2 by 3 matrices, the 3-dimensional 2 by 2 by 3 matrices. What are they? This is 2 by 3. This is 2 by 3. That part is 2 by 2 by 3. Are you getting it? Right? Like this, right? This kind of blocks you will have 4. This is one block. This is another block. This is another block, and this is another block. When I say there is 4 blocks, right? You see this additional bracket here. That bracket is enclosing. It is very simple. Numpy arrays are very simple. If you understand this, that last 2 numbers represent rows and columns, the number before it represents the box on top of it. The number before it represents n dimensional arrays you can create and you can play with. Got it?
Yes, Ram.
So the use of computer and calculator is only there when you are able to do these kinds of complex calculations. Human beings cannot create these kinds of big matrices and play with them. But when you have a computer, right, you will be able to play with them. So Numpy actually makes our life easy in playing with these kind of multi-dimensional arrays. We can go up to 5 dimensions. 5 dimensions is also not very often used. Okay, so 3 dimensions and 4 dimensions we'll use. 4 dimensions we'll use extensively. Okay? Even in our course, we have code examples that uses 4 dimensional arrays. Okay, so this concept you need to remember.
Sir, in Numpy, we can make use of only multi-dimensional arrays or any other arithmetic calculations we can make use, sir?
We can. I'll show you. I'll show you. I just showed you how to create one-dimensional, two-dimensional, multi-dimensional arrays. Now I'll show you the manipulations. What we can do. We can do all linear algebraic calculations in Numpy. Matrix multiplication, transpose, eigenvalue, eigenvector decomposition, singular value decomposition. We can do all that, right? With a simple method called linalg. Numpy.linalg is the package. Let me show you that.
Sir, what is the project at high level? How are we going to use the Numpy arrays?
I'll show you. I'll show you, sir.
Or whatever it is at high level.
I'll show you. Today, that is the concept. First, you need to know what is Numpy.
Sure.
And then I'll show you. Maybe today, tomorrow, right?
Sir, Numpy is also like a pandas module, but pandas focus only on the plotting the charts.
No, Numpy is not pandas module. Pandas actually uses Numpy as the backend.
Okay, can you say some differences with pandas and Numpy, sir?
Pandas data frame will have column names, right? Numpy arrays will not have column names. These are pure mathematics. This is pure matrix. This is right? In mathematics. However you use matrix, you can use Numpy arrays as like that. Okay, and Numpy array does all the linear algebraic calculations. Okay, but the pandas data frame is a wrapper on top of Numpy array where you can actually do the plots, graphs, and the statistical methods. It is like I have given you a dictionary and you wrote some code which actually tries to give me count of all the distinct values in the dictionary, something like that, right? If I import your module and say I create a dictionary and pass it to your module and call a method count, it will give me count. Like that, there will be more methods written on top of Numpy array. Am I making sense in explaining?
Yes, sir. Is there any statement we have both pandas and Numpy in one line, sir? Any command?
Command, I didn't get it, but if you have to explain in a simple statement, right? Numpy is for linear algebra, matrix manipulation and linear algebra, Numpy. Why linear algebra Numpy is needed? Either it is a data frame or a machine learning algorithm. Behind the scenes, linear algebraic calculations happen. So when you build a machine learning algorithm, it actually takes the data and converts everything into Numpy array and then does the matrix manipulations and brings back the result. I'll show you that. The whole, whatever the pipeline, I'll show you.
Okay, sir.
Right? Give me like maybe half an hour to 45 minutes, and if I am still unable to answer your question, right, I'll stop and you can ask questions.
Okay.
Okay. So yeah. So we actually got to see how to create multi-dimensional arrays. So there is method called as ones. Right? Ones will create arrays with all ones. Empty, it depends on the current situation. It's a memory situation. If I created ones, right, it will actually pull all ones or zeros. Like, depends. The empty method will actually pick up one memory location. Whatever values are there in that memory location, it will pick. Empty method I never used. I don't even suggest also. I didn't understand why they created that empty method. Okay. If you get time, look into API, you may understand. This I is a method which actually creates an identity matrix. You know identity matrix, right? All the diagonal values are going to be 1, non-diagonal values are going to be 0. When you multiply any matrix with identity matrix, you get that matrix only. It is like number 1 in numbers. Right? In matrices, identity matrix is equal to 1 in your number. Multiply that matrix with any matrix, you get that. A into I is equal to I into A is equal to A. Okay, so easily you can create. If you have to create this kind of a structure and then do manipulations, right, it is difficult. So let us try to see how to create a one-dimensional array. Right? Arrange is a method which actually takes the the start and stop and step. Okay, if I remove all this, let me try to remove all this and put 32 only. It created one-dimensional array with 0 to 31 numbers. Do you see any this kind of a method in Python which actually creates numbers like this?
Range.
Range method actually creates numbers. They added a in front of it. That's it. Numpy.arrange creates a one-dimensional. So this is also useful. Many places, right? Maybe ones and zeros are useful, but arrange is also useful. So you can actually do start, stop, and step. I can start the array at 5 and stop at maybe 15 and step 2 at a time. What is step? It starts at 5, 5 plus 2, 7, 7 plus 2, 9, 9 plus like that it is. See that? 5, 7, 9. But the last number it is not going to create, even though it can do that 15. That rule we have seen in slicing, right? It will not take the last index and try to produce that. Right? So same thing here also, the last number is not going to produce. Here 13 plus 5 is 13 plus 2 is 15, but it did not generate because that's the last number. Okay, so we created a numpy array, right? So I'll just take the 32 and 2 because we'll have more numbers. And then if you look at shape, it gives you the dimensionality that there are 15 numbers, and you can use reshape method to change the shape of the matrix. This is one-dimensional array. How do I know? If I say endim, it will give. Or if I look at the shape, it will actually show me in brackets like 15 comma what. I said this is a tuple, right? If I say 0, I'll get 15. On a tuple, you can do indexing, right? That is a tuple. Numpy array.shape is a tuple. On a tuple, you can do indexing, right? If I say 1, what happens? If I say 1, what happens?
It will throw error.
Error, index out of bound, right? It has only one number in the bracket, right? So one number in the bracket, that means the tuple has got only one value. Okay, so that's also important. We'll actually play with the code. While playing with code, right, shape of we'll do. Okay, so whatever I am speaking right now here is all used in our code. Okay, so reshape is the method which actually reshapes the dimensionality of the matrix. You can convert a one-dimensional array into multi-dimensional array. Again, a multi-dimensional array into one-dimensional array. Okay, reshape method does the conversion from one dimension to multi-dimensions. So there are 15 numbers right here. I can convert into either 3 into 5 or 5 into 3 because 15 is equal to 3 into 5. I cannot convert 2 by 5. If I say 2 by 5, it will throw error. 15 is not a, you cannot produce 2 into 5 is 10, but not 15. Right? You can do 3 by 5 matrix, 3 rows and 5 columns. Reshape method will, if you don't have this variable assigned, right, it will just show you that it converted. If you assign the value gets assigned. It is like if you use a data frame with in place false In place false, it is not going to make the change in the object, right? Like that it is. Reshape object will not affect the, will not change the values inside the numpy array. It will just show you. You definitely need to assign it to a variable. Okay. Numpy dot reshape 3 by 5, or I can do 5 by 3. Okay. 5 rows and 3 columns. Okay. This is a reshape method. So I can do a 3-dimensional one also. See, 1 by 3 by 5 I did. Now if I create a maybe 33, there are 16 numbers. Now I can convert it to 2 by 2 by 2, right? I can convert it to 2 by 8, right? 2 rows and 8 columns. Now I can convert it to 2 by 2 by 2. Oh. 2 by 2 is 4, 4 2s. Okay, 2 by 4 maybe. Right. It's a 3-dimensional array. 2 by 4 is the 2-dimensional matrix. Two-dimensional matrix enclosed in another bracket. There are 2, right? So I can convert a 1-dimensional array to any dimensional array, provided that number of items in the array matches the dimensionality. Right? Got it, right? Any questions there?
Yeah, Rama. So what is the use of this reshaping?
We'll see. It is all going to be useful in our deep learning course, and definitely we have to reshape. Definitely we have to change the shapes and all that. These all methods are useful.
Okay.
I cannot explain that now because in deep learning we'll see, but I'll show you some examples in maybe in 15-20 minutes, so that you'll get a little bit of idea there. Okay.
Yeah.
So here, yeah.
Excuse me. Can't we use here in place to make it?
No, that is
Instead
not
of-
provided in the if you look at
NumPy.
NumPy arrays reshape attribute, that API is the.
Okay.
Somebody wrote that method and they whatever they give, we can use. In place is not there. New shape and order, right, whatever. But resize is another method which actually applies the change. Resize. There is another method called as resize, which applies the change right away. Okay. You should use resize method rather than reshape method. Okay. And then ravel is a method which actually converts a multi-dimensional array to 1-dimensional array. This we will use very extensively. Okay, this we will use very extensively in deep learning and machine learning also. One example I'm actually thinking right now. Suppose that there is some method you wrote and it is giving multi-dimensional array, and you wanted to add that multi-dimensional array to your data set as a one more column, right? And the number of items actually match your number of rows. Then you should ravel it and append it to the matrix. So you will actually process data and you get it from other places, and that other places data may not be in the form you wanted. Then you can use reshape and ravel methods to change the shape of it and append it to the data set. It is like you have 10 rows and 5 columns, and you have got maybe 10 more rows and maybe 20 columns, and you wanted to make it 20 rows and 10 columns, or 20 rows and 5 columns. You can actually use the reshape and ravel methods to either convert it from one dimension to another, like the multi-dimensional to single dimensional, or single to multi-dimensional. We'll see all those applications. Don't be worried about applications. Just look at these methods given, and we'll definitely see them. So any questions so far? The reshape and ravel you understood, right? Understood, right? I'm moving on.
Sir, can you just explain ravel again, don't mind?
So ravel is simple. You see this np.array4 is a 2-dimensional matrix, right? And I just called Ravel on top of it, and it actually converted my matrix into one dimensional again, back to one dimension. Okay. It is like I took one dimensional array, converted to two dimensional, three dimensional. Again, if I want to unfold it and make it a one dimensional, right, I can do it using Ravel. So you have bidirectional, transformational methods. Okay. And now you can do
sir. So Ravel always converts anything to one dimensional array.
Yes, any array to any dimensional. Whether it is 10-dimensional matrix, also you pass Ravel, you call Ravel, it converts to one dimensional.
Got it.
That is very useful. That is very useful. You will see that when you are actually working on code.
So again, if you want to change it into multi-dimensional array, we need to use reshape.
Reshape or resize. Resize will actually make the effect applied onto the NumPy array. And resize will just change it and show you. And if you see this, right, there is when you look at data frame, I think I'll just show the. So if you look at data frame, when you print, see that it looks like a table. It looks like a database table, right? But when you look at NumPy array, it looks like raw skeleton, right? Raw matrix it is, right? So that's the major difference. And in this, right, the methods are going to be different, right? In this you have the mean, median, mode, standard deviation, and all. Even NumPy also will have it, but here we'll use it in data frame. We'll use it. And one more thing is when you are trying to do activity that's going to take more iterations and more processing power, generally going with NumPy arrays is easy. Is easy in the sense it actually processes very fast. I'll show you one example. Whatever we worked on, I'll show you one example there. So when you use NumPy arrays, right, the processing power comes down by it used to take around 5 minutes, the process. When we converted everything to NumPy array and made it work, right, it was taking around 0.6 minutes, 0.5 minutes, like maybe 30 seconds. What is 5 minutes and 30 seconds is like tenfold, right? Tenfold improvement it will have. Okay. So NumPy arrays are faster compared to data frames, but data frames will have more features to do data pre-processing and understanding. The statistical data analysis and pre-processing can be done easily. NumPy arrays are useful in doing linear algebraic operations. Why linear algebraic operations? All machine learning algorithms are linear algebraic operations only. Behind the scenes, linear algebraic operations happen. Now, in the front, right, you may be calling one method saying fit. Internally, it does lots of linear algebraic calculations. So, do we need to know? Yes, we need to. In deep learning, we'll use the NumPy arrays, explicitly. We write code and use it. In projects also, some places we may have to use. I'll show you one example. Okay.
Sir, one more question. So is it correct understanding that NumPy arrays deal with only numbers, nothing else?
Generally, yes. We can actually create NumPy arrays with strings also. Like, let me show you. That's a good question. So I said that the data is homogeneous data, right? Let me try to take one of the values. I am changing it to Rama. Okay. I'm creating a two-dimensional array here. One of the values is Rama, right? See that everything else got converted to string, right? If you see the data type here, it's showing some Unicode, whatever, right? Everything got converted to string. Got it? You can create a string NumPy array, but generally it is not the purpose of NumPy array. Linear algebraic calculations is the purpose of NumPy array.
Sure.
Right? We learned matrices, right, in our childhood. All those matrix manipulations we'll do using NumPy arrays now. Okay. That's a good. Okay. So here the dot method, right? Np.dot AI I have a method. I have a matrix A. Now I created a matrix A here. It's a 3 by 3 matrix. See this? How did I create? NP dot arrange of 9 will create numbers from 0 to 9, 0 to 8, right? And then I did reshape of it. Reshape by 3 by 3 because 0 to 8 are 9 numbers and I reshaped. I've got A and this is a 3 by 3 matrix. Right? I'm creating a 3 by 3 I is the identity matrix and I'm multiplying A into I. When I multiply A into I or I into A, I'm going to get the same matrix. See this here? NP dot method will actually do the dot product or the matrix multiplication. What is matrix multiplication? I'll show in a moment. Okay. What is matrix multiplication? I'll show in a moment. So you can do it like this or you can do it like A dot of I. You can do like that also. A numpy array has got a method called dot and you pass the matrix with which you want to multiply. Okay. There is scalar multiplication and matrix multiplication. I'll show you those differences in a moment. Right. You can use either way. Right. NP, I think I should put it this way here. The array dot of the whatever matrix other matrix or NP dot I comma A. Right. Either way you can do the matrix multiplication. So this is matrix multiplication. What is matrix multiplication? I'll show you. So let us look at a little bit of linear algebra and then we'll go back to the numpy. So this is a two-dimensional matrix, right? These are all two-dimensional matrices. So here a square matrix I have taken, a rectangular matrix, a column matrix, a row matrix, and a square matrix. For example, I have taken. Okay, if you do addition of two matrices, the dimensionality must match. Which dimensionality? We have this 2 by 2 matrix, right? Either rows or columns should match. You can add this matrix with this matrix, this matrix, and this matrix. Not this matrix. A cannot be added to B. A can be added to C, D, and E. I'll show you why. Okay. These rules we should remember, or it is a refresher. We know we have learned it long back, but it's a refresher. See this A plus E. When I try to add two matrices, what happens? The corresponding index values will be added. Right? 5 and 8 gets added. Right? 3 and 5 gets added. 5 and 3 gets added. 1 and 3 gets added. Right? This is a 13, 8, 8, 4. Okay? This is a matrix addition. When the dimensionalities are same, the corresponding elements of the indexes will get added. This is clear, right? Can I move on?
Yes.
Yeah.
Very simple it is. I can move on. See this here? I am trying to add a two-dimensional array with a column array. Then either the number of rows must match. If it's a column matrix, right? Number of rows must match. See this 8, 3, 5, 1, 2, 3. So 2 gets added to the complete row, 8 and 3. The 3 gets added to 5 and 1. Okay. So this is called as broadcasting. What is getting broadcasted? The 2 and 3 matrix is getting broadcasted to the 2 by 2 matrix. The total matrix is getting broadcasted. In machine learning language, they call it as broadcast. It is just simple matrix addition. Right? In articles and the books, they write broadcasting. When you try to read something from the middle of the book, right? Again, you have to start from the beginning and understand. Just to know what is the broadcasting, you may have to go back to the beginning of the book. So to save time, right, I'm putting these kinds of terminology in the course. Okay, this is called as broadcasting. This 2, 3 broadcasted throughout the array and calculate. So the number of rows should match. Okay, that is one kind of addition. Number of columns should match. If it is a column row matrix, right, the number of columns should match. This 2 should match. Now what happens? It gets broadcasted in the column direction. First column gets added with 4. Second column gets added with 3. Okay, we get like that. If you add a number to the matrix, right, this is called as scalar addition. This number gets added to the total matrix. See, 8 plus 10, 3 plus 10, 5 plus 10 and 1 plus 10. That's the matrix. So this is matrix addition. If you want to add this matrix with this matrix, right, A with B, it will throw error because the rows matched but columns did not match. Right? If your rows match and column did not match, it should be 1. If columns match, rows did not match, it should be 1. Both should match to do addition. Okay, got it? No questions, right? Scalar addition, broadcasting. This is also called as broadcasting one. Okay.
Sir, can you tell me so one negative case in this scenario?
Negative?
Negative case. So rows and columns will not match, right? Anything.
This one, right? A and B. A and B, I
Yeah.
did not add it here, right? If I do
Okay.
that numpy addition, right? You will see that error. Maybe we'll do that numpy operation here, right? I'll take two matrices and then try to do the matrix additions here, and then you will understand. Okay.
Yeah.
Let me take maybe name H. H is equal to np dot arrang arrange of how many 2 by 2, right? 4 dot reshape of 2. Okay. That's a 2 by 2 matrix. Okay. Let me print H. Yeah, that is a 2 by 2 matrix. Let me take another numpy array, right? With so I am taking another 4 by 4 matrix. H I I'll take. I think I took already I, so J I'll take. Okay, and then multiply this with the 2 and print it. This is what? J, capital J it is. Okay. These are 2-dimensional matrices. I can add, right? H plus J will work. Right? 0 got added to 0, 1 got added to 2, 2 got added to 4, and 3 got added to 6. We got it. Okay. Now I am creating a column matrix. Okay. How to create a column matrix? K I'll take, and then I am going to take to 2. I think plus 1 I'll do. Right. Reshape of column matrix means what? 2 rows and 1 column, right? I am doing plus 2, right? I am going to print it. That it's a 1 column matrix. It is okay. There is like your understanding. I am out of my finicky nature. I'll just show this kind of a matrix I create. C kind of a matrix I create. Okay. So now I can add a H with K. Oh. K I can do, right? See that? What is H? 0, 1, 2, 3 H, right? I added 0 to 2, 1 to 2, 3 to 2, and 4 to 2, right? It worked, right? And then I'm going to create a row matrix. How to create a row matrix? Do I need to reshape? I can reshape or I cannot reshape. Even in both cases it works. Let me show you. Row matrix means 1 row, 2 columns, right? This is L, I'll take, okay, and then L, right? I can add H with L, H plus L. See that it added, right? H, what is H? Let me try to print H here again. I'll stop the movement, okay? I'm actually going a little faster. Print H, right? 0, 1, 2, 3. I'm adding this L matrix to that. So 3 gets added to 0, 3 gets added to 2, 4 gets added to 1, 4 gets added to 3, right? 3 plus 5, 3 and 5 and 4 and 7. Sorry, 5 and 7. Right? 4 plus 1 is 5, right? So that is row matrix getting added. I said that even if you don't reshape it, it will work. When you don't reshape it, it's going to create a 1-dimensional array, right? See that it still works, right? Even if it is a one-dimensional array, it works. But on a column matrix, right, you should definitely reshape. Rather, it will not get that rows and column structure. Getting it, right? What am I actually talking about? You're getting it, right?
Yes, sir.
So let me create that negative example. HIJKL I'm creating. Okay. So let me take this. Copy this. I'll copy this. M. So what is the M? 2 rows and 3 columns I need. That means 6 numbers I need, right? 2 rows and 3 columns. Maybe we'll take 5. Yeah. So that's a 2 rows and 3 columns. Now the negative example is if I try to add H2M, see that? This is what you wanted to see, right?
Yes, sir. Understood.
Who is asking the question?
Yes, you know, sir.
So that's like, the linear algebra. It is linear algebra. There is nothing in Numpy arrays. Numpy array implemented linear algebra. Matrix addition, it already implemented. If you take 2 lists, right, try to add, what happens? We have seen that, right? If I take 2 lists, 1, 2, 3 plus 3, 4, 5. What happens? If you add these two, what happens? They get concatenated and creates a new list. It is not doing matrix manipulation. Matrix operations are not possible in normal lists. Any language you take, arrays or whatever you take, the matrix manipulations are not possible. When you actually pass the plus and pass the matrices, right, it is doing matrix manipulation. That's the beauty of Numpy arrays. Getting it, right? The advantage or the facility provided by Numpy array. Got it?
Yes, sir.
Okay, so we'll see more, right? Matrix subtraction, same rules apply for matrix subtraction also. A two-dimensional array can be subtracted, and it is element-wise subtraction. You call it element-wise subtraction. This element, this element, this element, this element. This is index-wise. It is getting subtracted. Two-dimensional array, column matrix, right? The dimensionality matched, rows matched, so it's going to get subtracted from rows. 2 is going to get subtracted from first row. 3 is going to be subtracted from second row. Again, the row matrix, right? Your column should match. 4 gets subtracted from first column. 3 gets subtracted from second column, right? And then you can do scalar subtraction also. You subtract scalar, just subtracts everything, right? From everything. So that is called as broadcasting. These column matrix and one-dimensional matrix and row matrix and the number subtraction is called as broadcasting again. Whether it is subtraction, addition, or multiplication, it is happening to more than one number, one index in the array, we call it as broadcasting. Now the matrix multiplication. Till here you are good, right? Any questions?
Yes.
Yeah, thank you. So here you take out this plus and put minus, right? It does all the matrix negative minus operations. There is a function called as add. np.add will also do the addition. np.add also does the addition. np.subtract also does it. Either you do plus symbol or minus symbol, or you use method, that is same. Okay. So it is like normal numerical manipulation kind of a thing. They did it. Numpy array actually gave us the facility to do matrix even if it is a million number matrix, it does it. That's the beauty of Numpy array. Okay, billion number also it does it, provided you have the necessary RAM in your computer. Okay, so the next thing is matrix multiplication. I think we would have seen this matrix multiplication long back and we would have forgotten it, right? So I took this 2 by 2 matrix and multiplying that with 2 by 3 matrix, or I can do it with 2 by 2 matrix or 2 by 1 matrix, because when you have to multiply two matrices, the number of columns in the first matrix should match the number of rows in the second matrix. M by n and n by p matrix can be multiplied, then m by p matrix. So when you multiply these two matrices, right, you get 2 by 3 matrix, because this 2 matched here. So how does that matrix manipulation happen? I'll explain you one real-time scenario. I'll take one real-time scenario and explain where the matrix manipulation is useful. So if you see this, the color coding is very important. I don't know whether you can see clearly or not. Okay. This first row multiplies this first column. Right? See this green arrow. It generates the first number. 8 into 2 plus 3 into 3 is the first number. Okay. 8 into 4 plus 3 into 1 is the second number. See the red colored arrow. Again, the blue colored arrow, 3 into 8 into 3 and 3 into 6, right? That's this number. Again, this row multiplies this column, this number. This row multiplies this column, this number. This row multiplies this column, this number. So that is ultimately the matrix. This is matrix multiplication. Okay. There is multiplication. There are two kinds of multiplications. One is normal dot product matrix multiplication, where we use this dot method. See this here, dot method. This dot method is doing the matrix multiplication, dot product we call it as. And there is element wise multiplication. To do that, right, we should use star symbol. We use star symbol, right? It will do element wise multiplication. The first element, second element, the first element in the first matrix and first element in the second matrix. Second element in the, like that, element wise addition we did, right? Like that, if you want to do element wise multiplication, you should be using star. You should know clear difference between star and dot. Okay, we'll use that in deep learning a lot. Okay, so you got this matrix multiplication, right? Any questions here? There's nothing to ask, I think, right? So you can do the matrix multiplication like so. Matrix multiplication is distributive. Distributive means A into B plus C is equal to A into B plus A into C. Okay, and matrix multiplication is associative. A into C into D is equal to A into C into D, right? C into whatever. But I actually took the dimensions very carefully and tried to put these A and C and whatever the matrices here. So these are all matrix multiplications only, right? Element wise multiplication, this is element wise multiplication. 8 into 5, 3 into 5, 5 into 3, 1 into 3, right? So now let us look at one example and then come back to this matrix, whatever theoretical concept. So if you suppose that there are some stocks, right? The stock 1, stock 2 and stock 3. A person, right, bought all these 3 stocks. Maybe person 1, person 2 and person 3. I'm actually trying to construct this example. I may get little bit of, I may get confused a little bit, don't be scared, right? So person 1, person 2 and person 3, three people have bought these stocks. Yeah, right. Bought at 10, 20, 30, 10, 20, 30, 10, 20, 30. They bought it at this price. Okay. And stock. Yeah. Now, suppose that stock 1, rose 10%, maybe 5%, maybe 2%. 2%. stock 1 rose 2%, right? Stock 2 rose 1%, stock 3 rose 3%. Okay. Now I wanted to see how much is the, maybe the value of the stocks is 10 rupees, 20 rupees, and 30 rupees for the first person, right? For the for different. Now I wanted to see after this raise, how much is the how much stock 1 value with person 1, stock 2 value with person 1, and stock 3 value with person 1. How can I do that? 2% raise means 102, I can say, right? This is all 101. This is 103. Can I say that? By 100. That's anyway there, right? By 100. Right? By 100. By 100. Right? That I can represent this 2% as this value, right? So if I multiply these numbers with these three numbers, I'll get the raise, right? So I can put these values like this. If I have to multiply these numbers and with these numbers and total value is 60 here, right? If I have to multiply these numbers, now I wanted to know the total value of that person, stock value of that person holding, right? So I can take this as a one-dimensional array. This is 1 by 3, and I can take this as a 3 by 1, right? 102 by 100, 101 by 100, 103 by 100. If I multiply these two matrices, this is 3 by 1 matrix. What I'll get? One value I'll get, right? This 3 will go. One value I'll get. 10 into 102 by 100 plus, right? When I multiply this row with this column, right? 20 into 101 by 100 plus 30 into 103 by 100, right? This is equal to 101. This is going to be 10.2 plus 20.2 plus 30.9. Total how much? 9 plus 2 plus 2 is 13. 3. 1. 3 plus 2 plus 6. Right? Here it was 60. After the raise in the stock, the person value became 61.3. In a single shot, right? I passed this matrix and this matrix, do manipulation. I got this first person's raise, right? How much value that person is. If I have 3 people matrix like this, I wanted to know how much each person values, right? Here, this guy is also 60, this guy is also 60. If I take this data, right? If I take this raise matrix 102 by 100, 101 by 100, and 103 by 100, and multiply this whole matrix with this raise matrix, right? I'll get values, right? I took intentionally the same values because you'll get 61.3, 61. I'll get a matrix again, a 3 by 1 matrix, which actually shows the value increase, new value of the person, right? If I have 1 million values also, I can actually do that. If I have 1 million people here, right? Person 4, person 5, like 1 millionth person, right? It is a 1 million by 3 matrix, and this raise in stock is a 3 by 1 matrix. When I multiply this matrix with this matrix, I'll get 1 million numbers. What are those 1 million numbers? New value of the person's stocks. Got it? Did the example is clear? Is the example clear, or should I write it again? Use of matrices I am trying to explain. Guys, should I explain again?
Clear, sir.
Anybody needs explanation again?
Yes, sir.
Should I? Is the screen clear? Right? I'm switching on the video and trying to teach. Right? Is that screen going smooth? Previously, it was getting stuck. Right?
It's fine,
Okay.
sir.
Okay. So let me clear this screen again and take one more and try to explain. Okay. and then we may do the same example on NumPy also. Right? Tomorrow I'll show you the machine learning example. This is what we do in machine learning also. This is what we do in machine learning also. And we do it in a large scale, and NumPy arrays actually help you do this. Okay, let me clear this off, or maybe I'll drag it a little bit upward and also drag it. Yeah. Now let me take the clear matrices, right? P1, P2, P3, three people, stock 1, stock 2, stock 3. This person bought stock 1 a worth of 10 rupees, 20 rupees and 30 rupees. Okay, this person bought a stock 1 worth of maybe 30 rupees, 10 rupees and 20 rupees. This person bought a stock 1 worth of 20 rupees, 30 rupees and 10 rupees. I am taking simple numbers here because the calculation becomes easy, right? So that is the right. Initially, when they bought it, the first person's total value is 60. Second person's total value is 60. Third person's total worth of stocks, in his pocket is 60 rupees or dollars. This part is clear, right? Yes.
Yes.
Yes, Rama.
Yeah, now I have, this guy bought these stocks on maybe Jan 1st, 2020. Okay. Now, today is November 11th, right? November 11th, 2020. November 11th, 2020. Okay. So today, the stocks actually rose by, first stock S1 rose by 2%, S2 rose by 1%, and S3 rose by 3%. I wanted to know what is the amount of what is the total value each person holds now. These three people, right? How can I do that? The first stock is 2%, right? 2% of 10 is 0.2. Right? This actually became 10.2. 1% is 2, 20.2. 3% is 9, 30.9. Each of this person, each of these stocks actually rose like, this is 0.2, this is 0.2, this is 0.3, 0.9 rupees actually rose. But I wanted to know all people's, stock values or total money they are holding in terms of stocks. So I can do a matrix manipulation and know it in a single shot. What I'll do is, what I did initially, I multiplied this number with this percentage, this number with this percentage, and this number with this percentage. If I do a matrix manipulation also, I can do it in a single shot and get this whole thing, right? Initially, on Jan 1st 2020, right? The S1 value is 100%, or no, like I can say no, don't get confused. Okay, so I'll actually take this as a column matrix, right? The column matrix is going to be 2%, 1%, and 3%. This is S1, S2, S3 is growth. Okay, I can represent this 1% as 2% as 102 by 100. Do you agree? 101 by 100, 103 by 100. Do you agree with this? Do you agree with this?
Yes, Rama.
Right? So I can take this as a one-dimensional array. Sorry, column matrix. Okay, this matrix is a 3 by 3 matrix. This matrix is a 3 by 1 matrix. Okay. Now, if I multiply this first row with this column matrix, what I'll get? Let me show you. 10, 20, 30. Right. This is one vector, and this is another vector. I call it as 102 by 100, 101 by 100, and 103 by 100. Right. When you multiply these two matrices, how to multiply matrix multiplication? This value, this number multiplies this number multiplies this number, and this number multiplies this number, and you sum it up. right? That's the matrix multiplication. 10 into 102 by 100 plus 20 into 101 by 100 plus 30 into 103 by 100. Right? That is the total matrix multiplication. This far you are clear, right? This far you are all clear, right?
Yes.
Now, when I do this calculation, I get 10.2 plus 20.2 plus 30.9. Right? That's going to be 61 point, I think 61.3. So 60 rupees of this person became 63 rupees after maybe after 9 months or 11 months, after maybe 10 months. The value of the 60 became 61 because of the raise. If I want to know of all the people, right, what I can do? Let me try to drag it up a little bit. What I can do, I can take this whole matrix, right? 10, oh my goodness. 10, 20, 30, 30, 10, 20, 20, 30, 10, and then the raise in the this thing, right? 102 by 100, 101 by 100, 103 by 100. Okay. If I do matrix multiplication now, what happens? This row multiplies this column, that becomes the first value, right? This row multiplies this column, that becomes the second value. This row multiplies this column, and that becomes the third value. How do I do that? This we already know, right? 61.3 we already calculated, right? Maybe I'll do it again. So 10 into 102 by 100 plus 20 into 101 by 100 plus 30 into 103 by 100. Right? That is the first value. Second, 30 into 102 by 100 plus 10 into 101 by 100 plus 20 into 103 by 100. Right? This row multiplied this column. Again this row, this 20 into this number, 20 into 102 by 100, this 30 into plus 30 into 101 by 100 plus 10 into 103 by 100. Right? If I do this manipulation, right, this is actually 61.3. We already calculated in the above. Okay. If you see this, this is going to be 10.6. 10.6 plus 10.1. 30.6, right? So, 30.6. 30.6 plus 10.1 plus 20.6. Right? This is 12 plus 1, 13, and this is also 61.3 only. Okay. For the second person also 61.3. Third person, it's going to be 20.4 plus 30.1 plus 10.3. How much is that? 4 plus 1.
30.3, I think.
Huh?
Middle one.
30.3.
Yeah. So 6 plus 4 is 10, right? And 60.1 it is. So the third person actually, third person gained less than compared to first one and second one because of the choice of stocks he actually chose, the number of stocks he chose from S1, S2, right? So in a single shot we are knowing that what is the growth in the value of these people's money, right? I have taken an example of only 3 rows here, but if I have 1 million rows, even then in a single shot I can get it, right? Do you agree? Then what I'll do, instead of taking this 3 by 3 matrix, right, I would have taken a 3 by 3, 3 by 1 million matrix, a big matrix. big matrix, 3 by 1 million matrix, right? These are going to be 3 only, 10, 20, 30, 30, 10, 20, and so on and so on and so on, 1 million. And the growth, right? This is the same matrix I am going to take. This is the same matrix I am going to take. 102 by 102 by 100, 101 by 100, 103 by 100, right? I'm going to multiply this. For 1 million people also, I will know what is the growth. Got it? Matrix multiplication is useful like this. Now you got it? 1 million or 1 billion, it doesn't matter.
Yes, Rama, got it.
Yes. Yeah.
So even in machine learning also we'll be doing this, and I'll show you once after NumPy arrays is over, right? I'll show you a simple example of linear algebra, linear regression, and how exactly the linear regression uses the matrix manipulation. So for today, right, I'll stop here, and tomorrow we'll continue and